Home Sweet Honeycomb, Sabellaria alveolata and biogenic habitats.
Animals and plants form habitats like mussel beds and kelp forests. These ecosystems are so complex that they lead to species richness. Hey ho, now don't you know there are biogenic habitats made by worms? Hey ho, there's sentiment choose make biodiverse reef systems. The honeycomb worm makes a right good home for the crabs and fish and many phyla. You see the honeycomb worms eco-engineer habitat for epibionts. Hey ho, now don't you know there are biogenic habitats made by worms? Hey ho, the sentiment choose make the largest reef in Europe.
The reefs look like a honeycomb, hence their name, honeycomb worm. Sabellaria alveolata begins its life in the plankton, spending from a few days up to 6 weeks in the pelagic phase until they settle on the hard substratum of the benthos. After settlement, they metamorphose into adults, and these allergenic engineers start building their reefs, forming tubes from sand grains and calcareous shell fragments, glued together by a strong mucus. The reefs undergo natural cycles of growth and decline and shift between different structural forms. Tubes of the prograding reefs are predominantly occupied by worms. New recruits and adults living in the tube prevent other organisms from entering as the worms filter feed everything that comes near. In the retrograding reef, a lot of the tubes are left empty and show signs of reef erosion. This leaves space for other organisms to inhabit, for instance, some highly diverse macrofauna, arthropoda and biofilms. A study of the St. Anne Reef used isotopic analysis to reveal how Sabellaria reefs modify food web structures, not just within the reef itself but in adjacent habitats. The reef structure provides a substratum for green macroalgae such as ulva and concentrates the biodeposits from its associated suspension feeders. This supports the buildup of microalgal mats on the reef structure and associated sediment. This facilitation cascade links the biogenic habitat with the associated sediment community by providing food for a wide range of organisms. The reef links benthic and pelagic systems as its increased height and hydrodynamic conditions around the reef promote the settling of pelagic larvae. Nutrients and phytoplankton accumulate around the reef, sustaining organisms in the reef and the associated sediment. Through habitat-wide gardening, alveolata maintain a stable trophic niche for themselves all year round. Isotopic analysis revealed the realized trophic niche of alveolata as well as the most abundant suspension feeders. Diversification of the trophic pathways promotes coexistence. This represents an expansion of the ecosystem engineer concept. The benefits to ecosystem functioning go beyond habitat provision by connecting the reef with associated sediment and the benthos with the pelagic system. The presence of epibionts on these honeycomb reefs can have both positive and negative effects on the overall structure and health of the reef. In a study by Dubois et al., they found that when there is a moderate density of oysters growing on the reefs, this will generate the highest species richness and diversity. However, once the population of oysters increases above moderate density, overall reef health starts to decline. They propose this is possibly due to the oysters outcompeting alveolata for food and space. They also stated that the oysters could benefit the worms by altering the topography of the area, increasing the number of crevices and therefore the surface area free for alveolata larvae to settle on. They also looked at the effect of ulva species coverage on the population structure of the reef. They hypothesized that a higher ulva density may decrease the recruitment of new worms due to an increase in the mechanical action of their fronds fanning the surrounding water. As well as boosting biodiversity through habitat provisioning, gardening of nutrients and facilitation of adjacent habitats, Sabellaria reefs provide key ecosystem services such as coastal protection and biofiltration. These valuable structures are under threat from human impacts. Colonization by oysters from aquaculture operations and algae resulting from excessive nutrient inputs threatens the otherwise stable reef system. A shift to high epibiont density is detrimental to the health of the reef and jeopardizes its valuable ecosystem services. Public harvesting of these oysters also means the reefs are liable to trampling damage. Although they are less well known compared to more charismatic coral reefs, understanding and communicating their ecological benefits is essential for conservation and restoration efforts in our changing world.
Hey ho, now don't you know there are biogenic habitats made by worms? Hey ho, the sentiment choose make the largest reef in Europe.